Hello, everyone. Welcome to our webinar. My name is Justin D'Souza. I'm a quantitative specialist at Statistical Solutions. During today's webinar, we are going to discuss how to conduct and interpret correlation tests. First, I'll give an overview of what tests can run, and then we'll go through a demonstration in SPSS and go through a sample data set, and I'll show you hypothetical interpretations. We'll send everyone a copy of the webinar and the PowerPoint. And at the end of the webinar, we will do a Q&A session. So if you have any questions during the webinar, you can just put them into the chat box or the Q&A box, and I will address those at the end of the session. My colleague Sierra has put some hyperlinks in the chat box for scheduling consultations and checking out the resources on our website. So yeah, just let us know if you have any questions. Right, first, I'll give a brief overview of the services we provide at our company. Then we will discuss the different correlation tests that you can run based on how your data was collected. I will give a demonstration in SPSS in terms of how to conduct these tests, and then we'll conclude with a summary and a Q&A session. On this slide, you can see all the various parts of the dissertation journey that we assist with, starting with topic development, going all the way to final defense, and all the chapters and sections in between there. We help with both quantitative and qualitative studies. So if you're doing mixed methods, we can assist there. We assist with the proposal chapters, so the intro, lit review, and the methodology, as well as prospectus and concept papers, depending on what college you go to. It may have a different name. We can help you with the IRB process and addressing the IRB questions. We can provide data entry templates for you if you're not sure how to organize your data. We can host a survey for you on SurveyMonkey. We have our own company account. And then we can also assist with the results chapter. So if you just send us your data and your methodology and any scoring instructions associated with your methodology, we can provide an APA write-up of the findings. Then we can assist with the discussion, PowerPoints for both proposal and final defenses. And then we can help condense your dissertation into a journal submission. If you have any questions about the assistance we provide, you can give us a call at 727-442-4290, or you can use the link that Sierra provided in the chat box. All right, so we are looking at correlations today, but I think it's important to lay the foundation first for what types of variables you can have. So in general, your variables will fall into three possible categories. You can have continuous, nominal, or ordinal variables. Continuous variables are usually numeric variables that fall on a continuum or a range. Examples of these include test scores, temperature measured in Fahrenheit or Celsius, weight in pounds or BMI or metric tons, or composite scores on a previously validated instrument. So if you are using Likert scale data and then building a composite score from those responses, that resulting variable would be considered continuous. So continuous, some synonyms for this, you'll see interval, ratio, or scale. Those are the three predominant types I see. Then you can have a nominal variable. So this is usually a variable that is categorical. There's no intrinsic order to the categories. So something like gender or ethnicity or race or passing and failing of an exam. These are all categorical factors. And then a subset of a nominal variable, you could have an ordinal variable. So an ordinal variable is a variable that has categories like a nominal variable, but there's a natural order or ranking or progression to the responses. So something like a multiple choice response on a demographic questionnaire for age, this would be considered an ordinal variable. However, if say on the demographic questionnaire for age, it was a fill in the blank response, that would be considered a continuous variable. Okay, so multiple choice, ordinal, fill in the blank, continuous. Another ordinal example would be just a single Likert scale question, something like strongly agree to strongly disagree, because you can assign numbers to these, like strongly agree would be a 5, 4, 3, 2, 1. Okay. So with that information, then in general, analyses will fall into parametric or non-parametric families. Parametric statistics are based on assumptions about the distribution from which your sample was derived. Usually, this assumption is that your data follows a normal or a bell-shaped distribution. So I'm sure everyone here at some point has seen a bell-shaped curve or normal distribution. That is the primary assumption for running parametric techniques. And a common format of using parametric analyses is when you have continuous variables. Okay, so variables like these at the top, you tend to use parametric techniques. So examples of parametric techniques for correlations involve Pearson correlations or point biserial correlations. Non-parametric techniques are not based on strict assumptions about the distribution of the data. So you don't necessarily need to have a normal bell-shaped distribution to run these analyses. Examples of these include Spearman correlations or chi-square test independence. We'll dive into those a little bit more. A little bit more about the normality assumption. If you've joined us before and you've seen my webinars, I've covered this more in depth about the normality assumption. So if you're running parametric stats, Pearson correlations, independent t-tests, ANOVAs, that sort of thing, you need to have a normal distribution for your variables of interest. There are many ways to check for normality. You can use objective tests like a Shapiro-Wilk test or a Kolmogorov-Smirnov test, in which a p-value is provided to you that tells you, does the data follow a bell-shaped curve or does it deviate from a bell-shaped distribution? You can also use skewness and kurtosis statistics, and you can visually interpret normality with EP or QQ scatter plots or histograms. So you'll want to check with your committee because there are so many ways to check for normality. You'll want to finalize with your methodologist or your chair what is the approach that they want you to use. You also don't want to use multiple methods for normality because you could see contradictory findings. Okay, and if the data does not follow a normal distribution, then you can consider using a non-parametric technique as an alternative. So for example, for the parametric technique, say we proposed Pearson correlations and the assumption of normality was not supported, then you could consider running the same analysis, but run it as a Spearman correlation. And if you have a very large sample size, then you can use the central limit theorem to justify proceeding with your original parametric technique, even if the tests of normality are not showing a bell-shaped curve. So the idea behind the central limit theorem is the larger your sample size is, the more it tends to approximate towards a bell-shaped curve. So I put a citation here that says that if your sample size exceeds 50 cases, violations of normality are not problematic. And so we've already covered these. Under the parametric techniques, we have Pearson correlations and point biserial correlations. A Pearson correlation is specifically used when you're testing the association between two continuous level variables. So for example, over here, if we're testing the relationship between test scores and temperature or composite score, any two continuous variables, you would use Pearson correlation. Point biserial correlation, the key prefix that you can see here is bi. So that indicates that you have a binary or a dichotomous variable. So for a point biserial, we need to have a binary dichotomous variable and a continuous variable. That would be, for example, if we're looking at the association between test scores, which is continuous, and gender. So is there a relationship between gender and what test scores males and females are scoring? That would be a point biserial correlation. And then going into the non-parametric family, the Spearman correlation is used for one, if the assumption of normality is not supported for a Pearson correlation, you can run Spearman correlations as a backup. Or if you have one variable that is measured on an ordinal level. For example, if we were looking at age like this, which is measured in a multiple choice demographic question, and we were correlating that with test scores, that would be an example of a Spearman correlation. And then finally, we have a chi-square test of independence. This is used when you're looking at the association between two categorical variables or two nominal variables. That would be, if we're looking at the association between gender, is male and female, and passing and failing of an exam, or ethnicity and passing and failing of an exam, you need to have two categorical constructs to run a chi-square test of independence. Okay? So in terms of the interpretations, there are three key statistics you should interpret when you're running correlations. And this slide specifically applies to Pearson correlations, point biserial, and Spearman correlations. So the first thing you want to interpret, and probably the most important value, is the p-value. So the p-value tells you, do you have a significant association between your variables? 99% of the time, this value needs to be below 0.05 unless you're doing Bonferroni corrections or adjustments. You'll see that the p-value needs to be below 0.05 to indicate a significant relationship. If it's greater than 0.05, then we don't have evidence of a significant association or relationship. Then you want to interpret the sign or the directionality of the correlation itself. If it's a positive correlation coefficient, this indicates a direct association. So as one variable increases, the second variable also tends to increase. If the negative or inverse association, that means as one variable increases, the second variable tends to decrease. The third thing you want to interpret is the magnitude. So what is the strength of the correlation coefficient? I've included Cohen's standard here, which is a common threshold used to identify the magnitude of the relationships. So if the correlation coefficient ranges between 0.1 and 0.29, that is a small association. Between 0.3 and 0.49, that's a medium or a moderate association. Any correlation coefficients larger than 0.5 are a strong or a large association. Okay, so we'll look at a Pearson correlation first. We'll go through an example in SPSS. So again, a Pearson correlation is a parametric analysis, and you need to have two continuous variables. And before we run the correlation, it's important to check for normality first. Verify with your committee what method they want you to use to check for normality. If normality is not supported, you can consider using Spearman correlations as a backup, or if your sample size is sufficiently large, then you can justify proceeding using the central limit theorem. All right, and I've put the instructions for how to run this here. Here I have a sample data set in SPSS. If you've joined us before, you've probably seen this spreadsheet. So we have 32 different car models, and across each row, we have mileage, we have the horsepower, what is the weight in metric tons, we have what type of engine does it use, is it an automatic transmission or a manual transmission? So to run a Pearson correlation, we need to pick two continuous level variables. In SPSS, this will typically be identified with scale designation here. So if your variable falls on a range or a continuum, if it has decimals as possibilities, that's usually a continuous or a scale variable. So for this example, we'll look at the mileage of the car and how does that relate to the weight of the car. For instance, the first thing we need to do is we need to check the normality. So we'll go to Analyze, Descriptive Statistics, and Explore. Then we will put in the variables of interest that we are looking at, which is mileage and weight. Then we will go to plots, and we're going to check mark the plots here, normality plots with tests. Click continue and OK. Okay, so this gives a lot of information. This explore option here that I just did, it gives descriptive statistics, it gives the tests of normality, it gives you QQ plots and box plots. But what we're going to look at primarily is this box here, tests of normality. And for these tests, you can see there are two columns or two different tests, the Kolmogorov-Smirnov test and the Shapiro-Wilk. Non-significance is an ideal finding for these tests, meaning we are hoping for a p-value greater than 0.05. The significance column right here are the p-values. So we can see that we have non-significant results. All the p-values are greater than 0.05. It's a good thing for this test. The normality is supported, mileage and weight. So this gives us the validity or the confidence to run Pearson correlations. All right, so we'll go to Analyze, Correlate, Bivariate. And then we'll put in mileage, this, and we'll put in weight. Make sure that Pearson is checkmarked right here. Should be by default. Then click OK. And this is the finding of our Pearson correlation. Going back to the PowerPoint here, what are the three stats we need to interpret? The first one is the p-value. Right? The p-value's under the significance row right here, and the p-value is significant. It's below 0.05. In fact, it's below 0.001. We do have a high level of significance between mileage and weight. The second component to interpret is the sign or the directionality of the correlation. So do we have a positive or a negative relationship? So going across the Pearson correlation row, we have negative 0.868 is our correlation coefficient. You'll see that the information repeats. It's the same information at the top right and the bottom left. So we have a negative correlation coefficient, meaning that as the weight of a car increases, the mileage tends to decrease. Intuitively, I suppose that makes sense. The heavier the car, the lower mileage. And then the third component to interpret is the magnitude. So this is where you use Cohen's standard, compare your correlation coefficient to these thresholds. And what we see in the example here is it is 0.868. 0.868 exceeds 0.5 here. So we have a large or strong association between mileage and the weight of. So first we had a significant relationship, it's an inverse relationship, and it's a strong association. Okay, now we can look at a point by serial correlation as an example. So what are the requirements for this? We need to have a dichotomous or a binary factor, and then we need a continuous variable. So I do have a couple binary factors here. I have transmission type and engine type. We'll use transmission type for the example. So before you use a categorical variable in a correlation, you need to convert it to numbers first. So you'll see I have the original transmission type here, and then I've recoded it into ones and twos. So one represented automatic, two represented manual. A lot of analyses in SPSS require a numeric format. And then in variable view, you can assign the categories to the numbers. So one automatic, two manual. All right. And for a point biserial correlation, we'll go to correlate and bivariate, the same menu we were in before. And you'll see that there is not a point biserial option. And the reason for this is that the calculation for a point biserial, it uses the same math as a Pearson correlation. So we just need to check mark Pearson correlation for this to do a point biserial. And we'll put in mileage, put in transmission type like that. And we can see that we do have a significant association between transmission and mileage. Right. Similar interpretations, we have a significant p-value, we have a positive correlation coefficient, and this value exceeds 0.5, so it's a large association. Now, I don't tend to run point biserials often because it doesn't give a high level of detail. For a comparison like this, I would do a t-test instead. It's going to give you far more detail, and I can show you that here. We'll go to compare means and then independent sample t-test. We'll set it up very much in the same way. We'll put mileage up here, and we'll put transmission type down here. So what this is going to give you is the mean mileage for automatic cars and the mean mileage for manual. What are the average mileage amounts for automatic and manual cars? That level of detail is not provided in a point biserial correlation, so I tend to run a t-test instead. And then we do have a significant difference identified. Okay, so for a t-test, we're not so much looking at associations or relationships or correlations. A t-test is looking for differences between two. So differences is the key word here. All right, so that's a point biserial. Then for a Spearman correlation, this is a non-parametric test. We don't necessarily have to have a normal distribution to run this. And we need to have at least one ordinal variable. What I've done in the spreadsheet here is I have mileage. This is the original mileage right here. And then I've converted it to different thresholds. So 10 to 16 was coded as a 1. 16 to 20 was coded as a 2. 21 to 25 was a 3. And then anything larger was a 4. So this is an ordinal version of mileage. Okay. And you can see I've identified the categories here. 1, 2, 3, and 4 represent. So for a Spearman correlation, we'll go to correlate, bivariate. And instead of the original mileage, I'm going to put in recoded mileage, 1 through 4, and weight again. Then just make sure that you uncheck Pearson correlation and check mark Spearman instead. Okay, then we'll click OK. And we do see still a significant relationship. Okay, so a significant association, that is the first bullet point. The second bullet point or the second statistic to interpret is the directionality. We have an inverse association. And then because this value is above a 0.5, it's a large or strong association. And then the final test we have is a chi-square test of independence. To run this, we need to have two categorical or two nominal level variables. An example of this would be if we're looking at engine type, and how is that related to an automatic or a manual transmission? So these are nominal because there's no intrinsic order to these categories. We have V-shaped and straight engine, and then automatic and manual. These are distinct categories. There's no order to them. On a chi-square, we'll go to analyze, descriptive and crosstabs. There's actually a couple different ways to run this. In SPSS, this is the method I tend to use. And then you'll put in engine type and transmission type. And you need to go to statistics right here. And this menu pops up right here. Check mark chi-square test. Okay, so chi-square, click continue, click OK. And the first thing it's going to present is a cross tabulation. Okay, so what is the combinations of transmission and engine type? So for example, we have 7 cars that were a straight engine type and were automatic transmission. We have 7 cars that were straight engined and a manual transmission. Okay. And then you can see the findings of the chi-square across this row here. So this is your chi-square statistic that you would report. This is the degree of freedom that you would report. And then this is the p-value that you would report. Now, the p-value is greater than 0.05, so we do not have evidence of a significant relationship between engine type and transmission type. Okay, so in summary, you will want to narrow down your research questions first, pinpoint what level of measurement each of your variables are using. Is it nominal? Is it ordinal? Is it continuous? With that understanding, you can then pinpoint specifically what tests you need to run, because the specific test you run is dependent on the level of measurement. So if you have continuous variables, you need to do Pearson correlations. You have ordinal variables, you do Spearman correlations. If you have categorical variables, you do chi-square tests. If you have a binary factor, then you can do point by serial correlations. And then you'll want to check for the assumptions. So checking for normality is the primary assumption for parametric tests. And if the assumption is not supported, then you can shift to a non-parametric technique, or you can use your sample size. If it is sufficiently large, use your sample size to justify proceeding. If we have any questions, you can type them into the chat box. I don't think we have any questions so far that I missed, but if we have any, you can type them in. If there's anything I went through too quickly that you'd like me to review, just let me know. And this is our company website, statisticsolutions.com. You can check out in the webinar archive here, see all the past recordings of the webinars we've done. And you can also see what is on the horizon. If you do free webinars, you'll see what webinars are being scheduled in the future. Okay, we have a question. Move the questions to a Word document so everyone can follow here. So can I still run a Spearman test when the variable is continuous but not normally distributed? Yes. That is actually a very good technique to use. So if you have a continuous variable, but the assumption of normality is not supported, then you can shift to Spearman correlations. A Spearman correlation is a non-parametric alternative to a Pearson correlation. We have a question here. Doing a webinar with multiple variables, controlling for one. I think I'll need to know a little more information. You could do that with partial correlations potentially, which is something I rarely see done. So that would just be putting in like weights and mileage while controlling the horsepower or something like that. That is a partial correlation where it is parsing out the effects of horsepower, essentially. So that's one way to do controlling for factors. Again, I rarely see that done, but you can also run potentially do a regression model. This would be like a hierarchical regression where you put your predictors in steps and your control variable in first, and then your primary predictors in the next step. I have done webinars on regression, so you might want to check those out. Okay, Eric, do you know what webinar you're looking for? Here, I'll put the link in the chat box for this. You can view all the webinar recordings at this link here. Responded to your there. And last week we did, there's multiple webinars every week. I don't know which one specifically, but you can put it in here. This is for everyone. You can view, you can find specifically which one you're looking for. I don't think I did one last week. I think last week was more literature. So the discussion, why is theory important? It was more literature based. Question from Chico. Let me move this question here. Likert type scales are already treated as ordinal, even if we use the total score. So this is a big debate that's spanned decades. My my preference for this is that individual Likert scale questions are ordinal. So if you're looking at one Likert scale question, that is an ordinal measurement. However, if you are generating a total score from that, meaning that you're summing together Likert scale questions, or if you're taking an average of Likert scale questions, that resulting variable is continuous. Because the new values go beyond the Likert scale. Once you take a sum or an average, so that resulting variable is often considered. Okay, so one single Likert scale question is ordinal, generating a composite score for a sum or a mean, that is continuous. Yeah, some great questions. Do we have any other questions? Okay, question from Aisling. All right, so I have three dependent variables and two independents. I know one independent, Ashling. My apologies. I have three DVs, so three dependent variables, two independent variables. I know that one independent has an impact on all three DVs. So looking to control for them. I don't know what this looking to control for that means. So you didn't mention a control variable. There has to be independent variables, dependent variables, and control variables. Right, with just independent and dependence, you can just do correlations potentially or regression models. If you do regressions, you would have to do three regressions. So it would be IV. You could do a multiple regression. So your two IVs predicting EV1 and just rinse and repeat. DB2 and DB3. three separate regression models. I don't think without a control variable, I don't think you need to do hierarchical regression. Okay. We have a question from Susan. Is it okay to report correlation coefficients in my dissertation when there is no significant or meaningful relationships? Yeah, 100%. It's actually APA format. I'm not sure if your school follows APA format, but reporting correlation coefficients, regardless of significance, is part of the APA way to report correlations. You would report it regardless of significance. And Apatunde. Is there a way I can rewatch today's presentation? We're going to email everyone a copy of today's presentation and the PowerPoint slides. Okay. Eric, I have an independent variable that measures a group score and an independent variable that measures individual scores. Do I use the mean for the deep? Would need to know more information about this. Fortunately, I can't give a lot of advice with this there. You have group scores. I don't know what group score means. Does that refer to collectively the sample score altogether, or does that mean a composite score? I don't know what the terminology means. I think I'll need more details. Question from Innocent. Excuse me. How do you tabulate an ANOVA using scores of a screening tool? Again, with just a sentence, there's not much information I can need more detail. But to run an ANOVA, we can look at an example here. Maybe that will help answer your question. So you go to Analyze, then General Linear Model. There's a few different ways to do this. But do a univariate, and then you put in your dependent variable up here, and you put in your independent variable factor box like this. Then there's a lot of options that you select. Again, this webinar was about correlations, not ANOVAs. I can't spend too much time on this one. And then you'll click OK. Okay, so this is findings of the ANOVA. So you would report this descriptive table that shows the mean scores between your groups. And then this is the most important row right here. Okay, so you would report this F value, these degrees of freedom, the 1 and the 30 here. This is your P value, which tells us we do have a significant difference. And then there's also a measure of effect size. Well, that's sometimes reported, not all the time. Question from Susan. Okay, I'm running a multiple regression analysis with several dependent continuous variables. Is there a way to run it in one model in SPSS? I would just do it as separate regression models. I don't think SPSS handles regressions with multiple DVs. So I think you would have to do a separate model for each dependent variable. Okay, so the number of dependent variables you have, that is going to be the number of potential regressions that you need to run. one regression per dependent. Okay. Any other questions? And Innocent, if you check out our webinar archive, if you go to the archive here, you can look at the tests of differences. If you just kind of scroll down through here, this one right here, I discuss ANOVAs more in depth. Put this in the chat here. Differences. I go into ANOVAs more in depth presentation. All right. Well, thanks for joining, everyone. Come join us for future webinars and let us know if you have any questions. Have a great day.